Hello everyone, in this video we're going to talk about equations of lines that are parallel and perpendicular. So we'll start off with parallel lines. So at the top of the screen here we see parallel lines and slopes. So a little bit about parallel lines and slopes. Two distinct non-vertical lines are parallel if and only if they have the same slope. So key word there, or key phrase, is same slope. So we're going to look at example 1 here. It says we want to write an equation of the line that passes through -4, 2 and is parallel to the line y equals 1/4 x plus 1. So we're going to write this equation in slope-intercept form. We already have our equation right here in slope-intercept form. So we know that the slope is 1/4, right? M is equal to 1/4. So if we want to write an equation of the line that's parallel, it needs to have the same slope. So we can start off with y equals mx plus b, and we're going to plug in 1/4 for x. Excuse me, 1/4 for m. So now we have this equation, y equals 1/4 x plus b. And we know that b is our y-intercept. X and y stand for any other point that's on the line. And so we have this point right here, -4, 2, that is on our line. So now we can take 2 and plug it in for y. And we can take -4 and plug it in for x. And once we solve this equation, it'll give us b. So we're going to say 2 is equal to 1/4 of -4 would be -1. And we add 1 to both sides, and we get b is equal to 3. So now we can take that and plug it back into our equation. And our final equation would be y equals 1/4 x plus 3. And this equation would be parallel to y equals 1/4 x plus 1. All right, so now let's talk about perpendicular lines and their slopes. It says two distinct non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. Okay, so opposite means one's positive, one's negative, and reciprocal means we're going to flip the fraction. Okay, so like if we have a slope of 2, its reciprocal would be 1/2, opposite -1/2. Okay, so we're going to do two examples with perpendicular. This first example actually deals with parallel or perpendicular lines. It says determine which of the lines, if any, are parallel or perpendicular. So we have 3 lines here. The first one is written in slope-intercept form, so we can easily identify the slope, and it is 2/3. Right, so the slope is 2/3. Now the next two equations are in a variation of standard form. So line B is in standard form, 3x plus 2y equals 8, and line C is kind of in standard form, but our y variable is listed first. So to make it easier on us, we can put both of these equations in slope-intercept form. So let's start with line B. Slope-intercept form, we want to solve it for y. So I'm going to subtract 3x. So now we have 2y is equal to -3x plus 8. And now we're going to divide all 3 parts by 2. So we get y equals -3 over 2x plus 4. Okay, so for line A, we had a slope of 2/3. For line B, we have a slope of -3 over 2. Okay, so we'll put a circle around these. There we go. All right, so for line C, we want to solve it for y. So we're going to add 2x to both sides. 3y equals 2x minus 9. And now we're going to divide everything by 3. So we get y is equal to 2/3 x minus 3. So now we can say the slope is 2/3. Okay. All right, so now we're going to evaluate our 3 slopes. So it says determine which of the lines, if any, are parallel or perpendicular. So if we notice, line A and line C have the same slope. So we could say line A is parallel to line C. All right, those 2 lines there mean parallel. So line A and line C are parallel. And then line B's slope is the opposite reciprocal, so -3 over 2. So we could say line A is perpendicular to line B. And also line C is perpendicular to line B, all right? Because lines A and C have a slope of 2/3. Opposite reciprocal would be -3 over 2, and that's the slope of line B. So A and C are perpendicular to line B. Line A and C have the same slope, so they are parallel to each other. All right, last example. Write an equation of the line that passes through -3, 5 and is perpendicular to the line y equals -3x minus 1. So very similar to the one we did earlier, but now this time the slope doesn't need to be the same. The slope needs to be the opposite reciprocal. Okay, so opposite of negative 3 would be positive 3. Reciprocal of that would be 1/3. Okay, that's what we need our slope to be. So we're going to start in slope-intercept form, y equals mx plus b. We're going to plug in our 1/3 slope, because 1/3 is the opposite reciprocal of negative 3. We have our x and our y. So 5 is equal to 1/3 times negative 3 plus b. 1/3 of negative 3 would be negative 1. Add 1. And we get b is 6. So we can plug 6 in for b. And our final equation would be y equals 1/3 x plus 6. And this equation would be perpendicular to y equals negative 3x minus 1. So that is how you find the slopes or use slopes to determine if equations are parallel or perpendicular.